Thank you. All right. Hello, everyone. So as I said before, my name's Ian McLeod. In addition to beekeeping, I do work at Red Hat as a developer. I'm currently actually involved in work around containerization, but another thing that I've done a lot of in the last 2 or 3 years has been involved with the Fedora project, which is sort of the upstream of the enterprise project that we release. And in doing that, I learned a lot about how that is put together, and so that's what this talk is about. So what is charcuterie? The talk is called Linux Charcuterie. So charcuterie is a French sausage, and it actually is more than a sausage, I'm sorry. It's a variety of ways of preparing meat, right? So it could involve, and that's actually, it's sort of a tease in this presentation that I say Linux charcuterie, and then I specifically talk about sausage. All of these things are delicious if you've never had any of them. But that's not actually what I'm going to talk about, right? So if you were here specifically to hear about sausage, by the way, please feel this is one of 2 opportunities to just get up and leave, and I won't be offended. So when I gave that, I mean, we're actually in Chicago here. When I gave this to a non-Chicago audience, I wanted to point out, like, does everyone know what we mean when we say you don't want to know how the sausage is made? Right? So yeah, that's most of us do. Upton Sinclair, The Jungle, and all of these things. So the idea for this talk came from a coworker of mine who said, although he's been using Linux for a long time, and he knew how to operate a distribution, didn't really know how all of the components went together. So you can go and get the source code for Firefox, but you don't exactly know the path that Firefox takes to get into your distribution. And I realized that until I really started getting more involved in Fedora, I didn't know a whole lot about that either. So I think it's interesting and it's worthwhile to talk about. And unlike not wanting to know how the sausage is made, I think actually this is you really do want to know about this. It's not ugly, it's not disgusting. It won't make you afraid to eat the sausage or use the distribution. Hopefully it'll make you a little bit more confident about it. So that was the genesis of this talk, and that's what I wanted to talk about, right? So what I'll talk about, this is specifically focused, I begin by talking a lot about Fedora, just because it's entirely open. It's what I'm most familiar with. I'm more familiar with Fedora than I am with the way that Red Hat's enterprise distribution. In fact, perhaps some of the scientific Linux people who are here could talk a little bit more about rebuilding the enterprise distribution. I'll talk a little bit about other distributions after I cover the Fedora release start to finish. I'll talk about some things that are changing the way that we conceptualize this process of putting together a distribution, and a bunch of source goes in one side and you end up with a DVD on the other. And the point here is, like, if you are, I apologize to the SL people who are here, but if you are already a person who does release engineering for a distribution, this may be a lot of duplication for you. And feel free to tell me if I've gotten anything wrong. So this is mostly, I think, interesting to people, or was probably most valuable to people if you're a user of a distribution but haven't actually constructed the distribution or don't contribute a great deal actively to it, so that you can learn a little bit more. So this is the second opportunity, by the way, to leave if you're worried about it. Although Sten's going to talk about something completely different afterwards. So, all right? You may be offended, right? And I hope at the end of this you'll understand what goes into actually making distribution versus what constitutes the upstream projects that build it, right? So I have a total gimmick here that ties back to sausage. I have 2 graphics of sausages here. Anyone who correctly identifies what this is, to my satisfaction, will get your choice of either a peanut butter or mint Girl Scout cookie. And if you don't get it right, the first person who even proffers an answer will get it. Yeah, okay. At least give it a type of sausage, Everett, please. Come on.
Pepperoni.
Pepperoni? No. 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 Kielbasa? No, it's not. Yes. Saucisson. Do you want mint or very good? So it's do you want mint? Okay. That's funny. These are the ones my wife told me not to give away. Don't take those. This was after she told me I shouldn't have bought them in the first place. So
Walmart has a very faithful replication of both of those ones.
Do they?
Yes, and they're actually slightly better, I think, because they're about $1.25 a box.
Okay.
And it's really fun to buy them at Walmart And then when the Girl Scouts are selling Girl Scout cookies outside of Walmart, they ask if you want to buy some. And you're like, well, you're $4 a box, these are $1.25. Give a lesson in economics, you know?
So moving on.
But then I give them a $20 donation anyway. So I make up for it, so.
I support the mission of the Girl Scouts, and I'm happy to pay.
Okay.
So what I'm going to do here, we're going to frame this. This was very loosely inspired by an improv comedy technique, although it's not funny. The improv comedy technique is you improvise a 60-second play, and then you compress it to 30 seconds, and then 15 and 5 and 1. Here we're going to start with a very short 60-second description of how Fedora is released, and then we'll actually talk about it. And I hope this is not meant to make a lot of sense unless you happen to already be very active in Fedora, but it should make much more sense when we refresh it in 15 or 20 minutes time. So this is the only slide I'm actually going to read. I know normally you're not supposed to read your slides, but this one's kind of important. So the Fedora release process. The old release is branched. The rawhide release accumulates packages and updates that are tracked in package.db and Bodhi and diskit, and they are built in Koji. The upcoming or new release, this will be Fedora 22, for example, if any of you are following this, is now branched. After that branch, we finish features and we complete them or we drop them. And we add progressive release criteria, and specifically for an alpha release, a beta release, and then ultimately the GA. When we do this, we create test composes and release candidates, and they're evaluated against the criteria to make sure whether or not they meet them. And if the deliverables meet the criteria, then we release the milestone. And if that milestone happens to be GA, then you have a new release of Fedora. That's Fedora in 60 seconds. And then we start over, by the way, and we just keep doing this over and over again. So the one thing that is missing from all of this is a huge accumulation of tools that enable this process, right? And the software that goes into it. And that's what we'll talk about, right? Possibly the single biggest, most important thing is a packaging standard that makes up the distribution. So who here has ever, who's installed an RPM package? Raise your hand, please. All right. Who has rebuilt an RPM package? Raise your hand. Okay. And who has built an RPM package from scratch? Good. Okay. So for the benefit of the 80% of you who've never built one from scratch and have maybe only rebuilt them, I'm going to go and review just what RPM is about and how an RPM is constructed. Because I think that the turning various upstream sources into sort of interchangeable widgets that can become part of the distribution is really more than any other single thing what makes this possible and makes it possible to do sort of repeatably insanely, right? So packaging, obviously, and most of this obviously applies also to Debian packaging and other things that you're familiar with, right? So it gives you a single view of what is actually installed on the system. Prior to packaging, you would download source, you would type make, configure, make, install, and it would just be there, and there was no unique way to see everything's on there. A lot of people still do that for certain things, but sysadmins don't particularly like that, and it's a very inconsistent way of constructing a system, right? So it lets you know what's there. Not only that, it lets you know what it's supposed to look like, lets you sign it, and lets you know if it's been changed by whoever is adminning the system or somebody else who wasn't supposed to. It lets you do updates as well. The one thing it didn't do originally that some people who are maybe have not used an RPM-based distribution in a long time may have heard of is it didn't originally do automatic dependency resolution, right? So whereas apt in the Debian universe has existed for a long time, longer than the comparable tools in Fedora, we did not have anything that did automatic dependency resolution. We've had a tool called Yum, which is now being replaced with a tool called dpackage that's existed for a long time. It lets you say, I want this and everything else that requires it. DNF, sorry. Yes, dpackage is the Debian, sorry. Whoops, slip of the tongue. So,
what's the new one called?
DNF. What does that stand for? Dandified Yum. Okay. I did not know that. I wish I hadn't asked. So that's a binary RPM package. That's what most people are familiar with. These are created from source packages, which is the thing if I've asked if you've rebuilt one, this is what you rebuild it from, right? So the original idea behind RPM source packages and the RPM packaging system in particular is that Linux was starting to be constructed with upstream software, right, projects that already existed that needed some level of modification in order to run successfully on Linux. Now this might just have been in the early days, it was actually sometimes the case that this was software designed to run on other forms of Unix. And it needed to be patched just for small changes and differences that existed inside of Linux. That's not as common nowadays. But there are also other things. You might want to make small changes. You might want to pull in particular enhancements. And you might want to pull in security changes. So the idea behind RPM is that you can preserve what came pristinely from the upstream project, what came from Firefox or glibc or whatever, and distinguish it from the changes that you've made, right? Not only that, you can know exactly what you did to make it build. You know what patch commands did you apply? How did you run configure? What other things did you do to change the build environment that the software provided in order to get it to produce the output you wanted? Once you've got the output, it lets you actually distinguish what different parts of that output are. So you can say these are binaries, these other files are configuration files. You could say these are configuration files that I would like you to not change if you are upgrading the package, right? So if you have your http.conf that has virtual host defined, if you upgrade because of a security errata, you don't necessarily want, in fact, you almost certainly don't want the configuration file replaced. All of this happens because, and happens sanely, because somebody took Apache, turned it into an RPM package, said that this particular file is config, don't replace, as opposed to config, do replace, things of that nature, right? If you've looked at it, and I think this is something that is optional but is pretty widely used in every RPM distribution I'm familiar with, you can see the changelog of the package itself. So you can look and see what versions, at what time was a particular upstream version of a package pulled in, when was that rebuilt. It shows you who built it, right, who actually took ownership of the packaging, and that can be very helpful. Another thing it does, once all of this information is captured, it makes it relatively easy to build binary packages, things that are actually compiled in something like C for multiple architectures. So when we, for example, brought online 64-bit ARM processors in Fedora, we were able to, in many cases, just go through and run the build again. All of this information was preserved, and we could get binary output almost immediately for 90–95% of packages. That just worked. And it's all controlled through this file called the spec, which I'll show next. Any questions so far?
Now, the changelog, that's the changelog for your spec file itself,
right,
not
for versions of the package. Yep,
right.
yeah. It usually, though, among other things, it will show you when a particular version of the upstream package was pulled in and what fixes it, yeah, right. So a spec file, is this a level of detail everyone's comfortable with? Is this useful? Okay, cool. I'll show you a specific example in a second, but just to go through what the individual components of it are. Spec file has a number of things inside of it. It has metadata that tells you, the package name, the package's dependencies, where the source came from, a short and a long description of it, other things of that nature. As far as the actual mechanics of doing the build, of turning the source into a binary, it has several additional sections here. The prep section is what we talked about, having the pristine source versus patches for security or functionality or to make it work with Linux. So the prep defines in a very prescriptive way how to unpackage the upstream source, how to patch it, and how to otherwise prepare it to be built. The build section, any of you who've actually built a large upstream package source, you know that there's sometimes several different ways that you're meant to kick off a build. Sometimes it's very simple, it's just run the configure command and run make. Sometimes it's a little bit more complicated. All of that is in this build section. And then the install, again, one of the things, actually, and I should have mentioned this earlier, when you build a binary RPM from source, you install, in the very early days, you actually ended up installing it on your live file system. This is sort of 10, 15 years ago. But for a very long time now, when you actually do the installation portion of the build, you install into a non-root area. You install into a staging area where you don't have to have root privileges. Anyone who's a non-root user can build this, and that's what install does. It does whatever's necessary, including changing the destination of something like make install to get the results of the build into that location. And then finally, the files section is what we talked about, distinguishes what actually should go into the binary package, and within the files that go into the binary package, which ones are documentation, which ones are configuration, and which ones are actually binary content and runnable. And the other thing that does actually is you can set ownership, because as we are running as a non-root user when we do all of this, if we have a package that needs to have files on the file system that are owned by root, we can't actually create those by ourselves. We have to say in the files section that this user bin HTTPD should be owned by root when it's installed, even though it isn't when it's in there. And it's all enabled by a very rich set of macros, sometimes almost exclusively macros, if you've ever looked into one. So this is a spec file, and now I actually have to, am I going to get out of frame, Carl? Just as well. We'll go into the two. So I chose ZSH because ZSH was talked about a lot last week, and a lot of people seem to like it. I don't actually use it, but who uses ZSH here? Raise your hands. All right, cool. So a few people. So this is the metadata portion, right? So we summary. This is where the source actually came from. In this case, it just gives a file name. Sometimes this is actually a URL, and then a series of patches, right? So this, I don't know what. I'm not actually familiar with what any of these specifically. Oh, this is an interesting one. So this is an enabling patch for running on 64-bit ARM, right? And I can see actually from the URL that Dennis Gilmore wrote it. So again, all of these things are distinct from the upstream source. So we know immediately what came from the ZSH project and what Fedora did to modify it. These other things are requirements for when we actually do the build step of this. It's saying that we need these packages present on the system in order for the build to complete successfully. So clearly it's going to use ncurses. I actually don't know why ZSH, we need to use libpcat, things like that. That is the metadata. The prep step, again, here's the macro you find in almost all of these that essentially amounts to tar and open it up, untar it into a specific location, apply those patches with those levels. The build step is in here too. Configure, again, this is another example of a use of a macro. So this is saying essentially run the configure command. Honestly, I'm not exactly sure what one of those options is. And then make all HTML, right? And then install. So this gets to what we were talking about, that you're not actually installing to the running file system, you're installing to an alternate root. So you see these RPM build root substitutions go on here. So we do a make install command. It ends up pushing the content not to the live file system, but to the build root. And then finally, this specification of what the resulting files are, right? And there are things like these are docs, so you can actually ask to have these excluded when you do an install. These are configuration files, and this specifically we were talking about, you can say a configuration file that should be replaced when you do an upgrade. Or it can be something that is not replaced. You can even, I think, say exactly where you want it, where you want the old one stored and what you want it to say if you do that. And then the changelog. So who's Dominic Hoff? Are you here? No? Dominic is the person who packaged this for Fedora. So that's an RPM. Any questions about that? Okay. The next thing in the Fedora process for this is called diskit. And this is where, in the summary, when I said a branch happens, this is what I'm talking about. So diskit is a place where we store everything that's necessary for making the RPMs for a particular release. And that applies to multiple release streams. So we have a diskit location for Fedora 20, which is a release that's been out for some time now, for Fedora 21, which was just released more recently. And as of a few weeks ago, we have a diskit location for Fedora 22, which is the upcoming release. And we have one for Rawhide, which is the sort of running, anything goes, most recent update thing. So in diskit is the spec file that we just talked about for any particular RPM that's in the distribution, all of the patches, and then a pointer to any binary sources, so a tar.gz that happen to be there. Tar.gzs are not, binary files are not very good to put into source control as a general rule, which is why they're not actually in there, but there's a reference to them that forms everything necessary to essentially make the source RPM, the input source RPM that would be used to build something. And because it's source control, it's all nice and clean. You can see who's done what, you can roll back, and it creates a nice history for each individual release. And this is actually, although you can do all of this with just get source control commands, it's actually assisted by a tool called fedpackage, which I don't have a whole lot more to say about, but is quite helpful in managing this. So,
Specific, it is literally a Git repository.
It is literally a Git repository with some conventions around how it's used elsewhere in the build system, right? And actually, that's not 100%. It's a Git repository and a little sidecar binary storage location where you can put the tar files. So this is the example for ZSH. This is actually the Git repository for that package that we were looking at earlier. So there's a branch for every Fedora release, and master, which always corresponds to Rawhide. It's the very latest that anyone wants to do. I didn't put every single file in there, but you can see these are the spec file, a number of the patches, and this thing called sources, which is actually a reference saying the one binary source file is called this, and it can be found in the upstream, then the binary sidecar storage under this hash. Again, because it's not a good thing to store in Git. So that's great. You've got a huge quantity of source packages, a huge quantity of patches to those source packages. It's all very nicely tracked. You know how to build it. Where do you build it? Any questions so far? Nope. So you build it in something called Koji. So Koji is both a piece of software and often is used to refer to the instance of that software that is used to build the packages for Fedora. Koji is awesome. If you are not a Fedora developer, haven't registered yourself as a Fedora developer, you're missing out on an enormous infrastructure and a cool set of tools. Also, even if you aren't registered, you can go and look at this, and you can essentially see every package build that has ever been done for Fedora, also for the extra packages for Enterprise Linux. They're all there. You can often, I believe there are actually people who make a business of looking at what builds are going on in Koji to do sort of assessments of where the industry may be heading or what Red Hat may be doing, because oftentimes things will happen here that obviously infer something. Oh, there's a lot of builds of Docker. I wonder if people are interested in Docker, and they, nobody makes any particular effort to hide what's going on in it. So poke around if you can. The URL is visible very clearly right here. But just to give an idea of the scale, so at the moment when I looked a couple of months ago, there were 40 servers running x86 that do the builds. There were more than that were doing 32-bit ARM. These are the primary architectures that Fedora builds for right now. There are additional Koji instances that these feed into for PowerPC, 64-bit ARM, and even System 390, which is mainframes. That actually has 10 mainframe slices associated with it. So it's really big, quite capable. And somebody pointed out, a lot of the time, this is actually sitting somewhat idle. It's this big in part because occasionally the project needs to rebuild every single package that makes up Fedora, which is about 30,000 packages. And we need for that to not take forever. So that's one of the reasons why this is so big. And I actually, okay, I think.
Are they native compiled?
They are. They are native compiled, yeah. So that's part of the reason. I've looked into this, so like for a 32-bit ARM and 64-bit ARM, it might be nice to be able to have a single piece of hardware that compiles for multiple architectures. But in the Fedora space, it's always on the native architecture, even though there's potentially ways to do that.
Is that for a technical reason, or?
You mean, well, I mean, as opposed to virtual machines?
Just to compile across our.
Yeah, there's not. I'm not aware of any consistently good way to get RPM to cross-compile. I think RPM spec files, correct me if anybody knows different, but it's very difficult. The RPM spec files define a way of building something for the native architecture that you're running on, generally speaking. There's no one.
One of the problems I ran into, just in general cross-compiling, is when you do, for example, make config, it's going to look at where you're running make config at. To make assumptions, not what your target ones. So
yeah, or to look at what the architecture is that you're running on.
The only way I found to get around this somewhat is to use let you run the C compiler on one box
and an extra,
and run the other stuff on another one. So you can have your compilation actually happen on a fast box, but you can have the configuration happen on your small embedded device.
Yeah, one of the benefits of being a fairly large project with a reasonable amount of support, both from Red Hat and from hardware vendors, is that we have 10 mainframes, right? Well, slices anyway, so that's cool. Anyway, yes?
On the Fedora build sys list, when you guys were looking at ARM64, Mike complained that Koji developer was talking about doing cross compiles, and the performance was just so terrible that you couldn't build a release.
Really?
Any
Was that?
because you lost so much CPU time on the cross compile it was talking about like 2 packages a day,
Yeah.
which is just not sustainable.
I imagine Drew is asking because at least, I mean, this is getting better, but when you're compiling for ARM, it's sometimes tempting to have a 16-core, the idea that you could have a 16-core, 2 gigahertz box doing the compile instead of a 1 gigahertz or slower embedded ARM board, but
Well, mostly because the AR64 hardware has been relatively rare and expensive. Like Leonardo has a cluster now,
Yeah.
and now there's some cheap AR64 boards. So, like that's been an issue
yeah.
previously.
No, the people I know in Fedora and inside of Red Hat who have the 64-bit ARM hardware have been very vocal about having possession of some of it, to the chagrin of all of us who are lesser geeks who have not been able to. John Masters,
Yeah.
yes, is one of them. To name one, yes.
Why is cross-compiling so slow?
I don't know.
I mean,
I didn't think it was. I thought certainly compared to, again, architectures where embedded architectures is where this is most useful, where the native CPU tends to be very slow relative to a desktop. But
I mean,
I know.
do you know if they're doing some like VM stuff, so it's not really cross-compiling?
I don't know, I just think there were some patches floating on the build sys list to allow Koji to say, well, I can virtualize this architecture, so I guess it'll work, and
No.
Well, like running-
shut them down.
Like running in QEMU or something.
Yeah, I.
No.
Okay,
Too
no,
close to it.
that's kind of explains it then. So I,
okay.
now we're splitting hairs as if that's really cross-compiling. Is
I would love to talk more about cross-compiling and ARM in particular, but maybe we could table it and talk about it offline. So, I don't know, I'm just... so just a little bit more detail about what Koji does and why it's so cool. It's sometimes, I said, even as one who originally approached this and have tried to set it up even, it can be a slightly confusing and intimidating, so I'm trying to do a very brief summary here that does it justice. The fundamental thing that Koji does is it allows you to categorize packages into groups, which it somewhat confusingly calls tags. A tag, for example, is something like Fedora 20 release. So you have a group of packages that are in this tag. This ultimately reflected the collection of packages that went in the Fedora 20 release. Tags can have inheritance. So Fedora 20 release, when it was initially created, inherited, for example, Fedora 19 and Fedora 19 and all of its updates. One, I think probably the single most essential thing to understand about a Koji is it has this idea of a build target, which essentially says, I would like to build this package, and I would like the build to have access to this tag that represents one group of packages, but I would like the output of that build to go somewhere else. Now, why is this useful? Let's say I, as a package maintainer, have a potential update for Fedora. I want to build that with Fedora 20 and all of the updates to Fedora 20, and I want the output to be a binary package. But I don't want that to immediately then go into the collection of valid Fedora updates because it hasn't been tested, nobody's given it anything. So you'll have a tag like F21 updates, or a target rather, for Fedora 21 updates that builds with everything that's already been released for Fedora 21, but then puts the result in this holding location, for example, Fedora 21 updates candidates, where it can get a little bit more testing and exercising and whatnot before it's sanctioned as a release. So if you log into Koji or just browse it, you don't even have to log in, you'll see that there are a lot of these tags, you'll see these things, and they all have to do with distinguishing what packages are available for building versus which ones are actually sanctioned as updates, and flowing things through that process. So this actually may work. I should have, and I hope there's nothing embarrassing in my browser history here. So this is the exact same, the spec file for ZSH that I was showing. This is the actual Koji build for that, right? So it preserves a number of the things that we could see in there, like the change log and the description. It shows us when it was compiled. Because it's actually been released as an official update, it shows us that it's in the Fedora 20 updates tags in this case. And then we can actually go and download, we can look at the logs that were used to create the build, which will show us the results of running configure. It's all there. So it's very slick, very helpful. And it's really essential to creating the release. So that's ZSH and Koji. A couple more things, and then we're almost done talking about Fedora, if you're not Fedora people. So we have a database of packages that just defines what you're even allowed to build in Koji in the first place, right? So before you can get a package into Fedora, you have to get it has to go through an approval process. It has to make sure that it has an appropriate license associated with it, make sure the source doesn't have anything that's obviously copyrighted. Once that's done, it goes into the package database, and that also establishes who's actually allowed to build it. So not every Fedora developer can update every package. Only people who are sanctioned for a particular package in PackageDB can do it. And this can be separated between releases. So you can have one person that is authorized to do the bleeding edge releases in Rawhide, but another person who's actually doing the maintenance releases. And you can also have people that are, for example, doing the packages that are associated with Enterprise Linux versus the packages associated with Fedora. Once these are built, we have one other system called Bodhi, which actually lets you take an update and say whether it works for you, right? So what I was talking about just a moment ago, where you do a build that is a potential update for the most recent version of Fedora. Once you're finished, it gets that tag that says it's a Fedora 21 update candidate. Somebody goes in and says, you get something called karma, if anyone ever heard of that? You give a build karma, say, no, it works for me, and that is what eventually pushes something out as an official update. I have some examples. These are not actually that interesting. At that point, we have a large pile of compiled packages, right? They're binaries. They could be installed on something, but what do we actually do with them? We don't have a DVD. We don't have a USB stick or a live system, so what do we do with them? We throw a few more tools in the mix that actually take a pile of packages that have been standardized and turn into these widgets that we can pop in and turn them into a release. And I think these are the last four. So there's something called MASH that takes a big collection of packages in a tag and turns them into a repository. So it takes Fedora 22 and everything that's supposed to be in it, and we can run this tool called MASH, and it turns it into a big Yum repository from which things can be installed. We have something called Anaconda, which is actually the thing that if you've ever installed Fedora or Red Hat Linux, or Scientific Linux for that matter, or CentOS, that actually does the installation, right? So it creates the bootable environment that allows you to do the install. So this actually is we could do a really deep dive on how Anaconda actually works, but it essentially takes the packages that are necessary to create a bootable runtime environment on something like a CD, lays them out, prunes them back so that they're not unnecessarily big, and then makes them bootable in an ISO so that you can bootstrap a system from essentially nothing. This is actually put into bootable media by two other tools. Lorax is what actually I mashed together what Anaconda and Lorax are. So Lorax is the thing that takes Anaconda, which is a package, and turns it into boot media. And Punji, or in other cases, do you guys use Punji for SL? Yep. You do, okay. I think we use something slightly different internally. Punji takes this bootable installation environment and adds all of the packages that MASH created back into it, and the end result is an ISO file that we can print out and give away at conferences, and essentially, we're done. Or are we, right? So we do this, and we do it frequently in the lead up to releases. And then we have a wonderful QA process, which I'm not going to do proper justice to here, that decides whether that end result is actually worthy of being called a release. So this is something that Fedora has done a great deal of work on, formalizing and publicizing and essentially making, bringing it out of the shadows, which has been a criticism of some other distributions at times. So they've established very clear criteria, and they're somewhat lengthy, for when is a release actually an alpha release. So these are things like, does the media even boot, right? It might be the case that you don't care if the ARM media isn't bootable for a release. In this case, we do, right? So each of these stages, we layer in criteria that say this must work, somebody must test it, somebody must sign off on it before we're going to actually do a release. So I'll skip over this. I think I'm going a little bit long. But once that, okay, so we have a few examples. Right, so things like, for example, translations or desktop backgrounds aren't necessarily necessary for an alpha, but they're necessary for final. And interestingly, a good portion of this, I think over half is what the people have told me, actually relates to running the installer. So a lot of the projects that funnel into this, like Apache or Firefox or whatever, are essentially mining their own house now. They don't release packages that don't work. They're generally pretty reliable. So in the lead up to release, a lot of what we end up doing is making sure that the bits necessary to actually do the installation work, which involves quite a bit of manual testing, unfortunately, in a lot of cases. So that's what QA does. And then when we reach GA, we're done with the Fedora release. I won't say it again, but this is, so hopefully more of what I said originally makes sense to everyone. This brings us to our second sausage. This again is going to change, because this is a Chicago audience, I'm going to give everybody be ready, and the first person who gives the most precise correct answer can have the peanut butter, so. Yes, this is Vienna. I'm sorry, Vienna beef. Yay! No one in California knew what this was. So, was it red? No ketchup.
Cucumber, sport pepper, and ketchup, celery salt.
Yep.
That's very, very important, the celery salt.
I told them everything, all of that. So
The 8 ingredients.
anyway, so moving on. I'm going to talk just a little bit now about some other distributions, and this is the one I said here: mild marketing on the RHEL slide. So Red Hat Enterprise Linux. Who's familiar? Who uses Red Hat Enterprise Linux at work? Raise your hand. Goody. Okay, so fewer than I'd hoped, but not nobody. So RHEL is actually the commercial product that Red Hat makes most of its money off of, right? It has for a long time been branched originally from what used to be called Red Hat Linux. This was actually the red box that you could buy at Best Buy and other places, and more recently has been branched for Fedora. So it is a stable release that gets supported on a life cycle that's actually closer to what something like Microsoft or Sun did. And this was really the key thing that allowed, I think, personally, this model is what allowed Red Hat in particular, and Linux more generally, to get penetration into places where previously we only saw companies like Sun and Microsoft selling. So RHEL is a Linux release based on RPM with a lot of the content from Fedora, but it's supported for at least 7 years. A lot of people pay us to support it even considerably longer than that. So I think, upwards, I think a few clients that are actually using the very first release that came out in 2001 or 2002 are still using it with some level of support from Red Hat. So this made a huge difference. It's 10?
Yeah, 10 years.
10 years.
3 year expanded.
Okay, see, now I'm not even doing justice. Some marketing person I am. Most of the tooling is actually identical to what's used for Fedora. The significant differences are we do not use Bodhi for errata. We have something separate. If you've ever heard of Red Hat Network, that's used to release updates. One big part of this is we need to be able to prepare updates and do all the testing and tagging of them, but not release them in any kind of public way because they may be embargoed security updates, which that's the meaning of the term embargoed. So some of the actual composed tooling, so we don't use Punji. I'm actually not sure exactly what we use internally now. Something derived from that. And the QA process is different internally. There's something called CentOS, and also something called Scientific Linux, I should mention. Yay, woo. CentOS is interesting in that it starts with the output of RHEL and then tries to produce something that is as close to it as possible as can be while removing the Red Hat branding and not necessarily having access to exactly the same build system. So that is the core of CentOS that's been around for, I think, at least since the release of Red Hat Enterprise Linux 3. They then add in a few things that are not part of RHEL but are of interest to people. I think the most notable thing in the Red Hat Enterprise Linux 6 timeframe is that they had a community that rebuilt support for Zen, which a lot of people like. This is a virtualization technology. And more recently, they've introduced this concept of SIG. So these are projects that want a stable base, so they don't necessarily want to be building on top of Fedora, which releases every 6 months. But they then want to do the ability to change out small portions of what's in the underlying operating system and to change themselves quite actively. I think the most notable of these actually is there's a SIG around OpenStack, if you're familiar with the OpenStack cloud. They like CentOS partly because it's very similar to RHEL, and a lot of people run OpenStack on RHEL, but also because OpenStack itself is just changing so rapidly that they can barely keep up with that churn, let alone trying to have a platform that's changing out from underneath them. Any OpenSUSE users here? Nice, okay. So OpenSUSE is a similar vintage to, certainly to Fedora and Red Hat Linux, maybe not quite as old as Slackware. Somebody used to say Slackware there. SUSE is interesting. At the time, for a long time, they were a major distribution. I think, a top-tier distribution where their build process was closed, and then they opened up after a release. So the SUSE company would come out with a release, and then a few weeks later, all of the sources would come out. It hasn't been that way for a long time. They now have something called SUSE Linux Enterprise, which is similar to RHEL, and their build process is entirely open. They have something that's comparable to Koji. They call it their open build service. A couple of key differences as compared to Fedora. The open build service unifies a lot of the things, at least the interface into a lot of things that are bulleted out very separately in Fedora. So the updates, testing updates, putting commentary on updates, all occurs in this single unified OBS interface, whereas Fedora sends you off to Bodhi to do updates approvals, and sends you to Koji to do the package building and a few other things. They also have the ability, which Koji does not do, to trigger builds of packages that say that they depend on you when you have updated that package. And this can sometimes be hundreds of builds depending on what the package is. So example, if they rebuild glibc, the core C standard library, the open build service can go and find every other C program and rebuild that against it. And I think the coolest thing they do that I would like to see Fedora and really almost everyone do more of is they have a very expansive automated QA testing process that things go through after they've been built, but before really any human hands lay on it. And this includes testing of things like the installer that involve interactive input. So I actually don't have a link to it, but they have a great demo of this. They'll show they will have something that says this subsection of the screen has to show up with this content by this time, otherwise it doesn't pass QA. So it'll be something like the splash screen for the installer, but without the actual installation number or the release on it. And this is the way that they are able to do quite a bit more automated testing. And I think I've spoken to some of the OpenSUSE people, and they said this may interest, as useful as it is, it's primarily a vestige of them having been a small, closed company. So they had to do all of this with a smaller group of people, and so they automated more of it, whereas Fedora and some of the more open distributions conquered this with numbers, they conquered it with technology. So that's openQA. If this, we're good.
I was going to ask, why did they open up the release?
I'm not sure.
Okay.
I think it may have been at the time because they were losing market share. So they needed to do something. I don't know if it was if someone actually called them license violations or anything. I don't think they didn't actually distribute anything that they didn't also distribute the source for, but they controlled the release very tightly. So maybe a few people have heard of this one, Debian. Yay, woo. So most of what I said about RPM, there's an analog for it in Debian. I think the most interesting thing for me that distinguishes dpackage from RPM is that dpackage is much less prescriptive in the way that you put together the input to a build. It's basically a make file. And what that's allowed dpackage to do is a number of different schemes or techniques for standardizing these files have been floated over time as sort of their own distinct projects. I forget, there's one that's only a few years old that's really gotten a lot of traction now. Now the name is completely escaping me. But essentially, this has taken things that used to involve flame wars on the RPM list about how RPM should build and eventually resulted in forking of RPM and allowed those things to instead exist as mutually compatible packages or competing packages within Debian to help enable building dpackages, which I think is quite cool. And more recently has allowed, a lot of packages that are built using these newer tools, the spec files or the equivalent of the spec files are extremely simple. And it allows you to sort of swap out things that are now done in an automated fashion or done using scripting that in Red Hat and Fedora are actually sometimes a little bit more painful to do. They have something that's equivalent to Koji. Roughly speaking, it's called buildD. The biggest differences with this, and again, this is not my area of expertise, but one notable difference is that Koji does not let you upload a binary package full stop. Right. Koji does the build for you. It does it in an environment that it has strong control over. The Debian build system has mechanisms to allow you to do this. And one of the interesting cases where this turns out to be really useful is if you have a package that it's a non-architecture specific package like the firmware for running an all software emulator of PowerPC that needs to be compiled, is most easy to compile on a particular architecture, but then is available to other architectures. So the original motivating factor behind this was to let something like that happen. So someone has access to their own special sauce hardware, they do the compile on, and then they upload the binary package. A couple of, well, I think I'm going to skip the Docker and Atomic portion of this because Sten's going to talk about Atomic, right? But I'll just talk very briefly about the first two. Fedora is 35,000 packages. It turns out to be very difficult sometimes to push through changes to all of these. And to apply the same standards to all of them. There's a little bit of stratification right now, but by and large, they're all treated as one monolithic group. So there's an idea that is being sort of gestated slowly here of having different categories, different rings of Fedora packages. So the real core essential packages may eventually be subject to something like automated QA and a little bit more rigorous testing, may not be allowed to be broken even in something like Rawhide, whereas some of the more peripheral things like, the nth recompilation of the Doom engine that runs with open, that isn't nearly as important. Another thing is that it's become more and more interesting to people to, one thing about Fedora and RHEL and a number of other distributions is that there is an official RHEL release of Ruby or the official native release of Python or a number of other things. And in some cases, and to a certain extent CentOS is dealing with this with the SIGs, certain people want to override these things, and there's really no convenient method within the Fedora infrastructure or the processes associated with that for someone to have, there's this compilation of Python that's managed by this person and this other one that's managed by another group. So there's something called Koper, which is essentially a build system that anyone can build in that creates its own repo when you're finished, and it doesn't matter if you're overriding anything that's part of the core distribution. This has been around for about a year. And it's gotten a huge amount of uptake already. If you just get a Fedora account and you can start throwing RPMs at this, it builds for all versions of Fedora that are actively managed and for RHEL, and they're talking about adding support for building for non-x86 architectures as well. So
Equivalent to PPA.
I don't know what PPA is. Yes, it is.
It's a cool other package repository or something like that.
As it
Yeah.
stands for.
Cool. This is another, two acronyms in my talk. I didn't know what they were. So, Cloud, Docker, and Atomic, we'll let them do. Yes, please, question.
So what versions of RHEL does Koper support currently?
5, 6, and 7, I think.
Okay.
Yes. So, all right. So what can you do? If you're at all interested in any of this, you should make your own sausage. Getting back to the sausage, right? So, in both Fedora and I think in Debian and others, you can adopt a package. So because there are 35,000 packages and people gain and lose interest over time, there are actually a list of packages that you could pick up. People really like it when that happens. If you have a piece of software that you favor that is not in Fedora, you can learn about how to package it. Probably the thing they would like it the most if you would do, and I know this applies to every upstream open distribution, is participated in testing. That goes for SL as well, I'm sure, and others. So you can test a package, or you can participate in QA. So in the lead up to these releases, if you're chomping at the bit and are interested to see what's going into it, you can participate in these QA days. They're all very widely announced, and again, everyone's very grateful for participation. Any other questions? Yes?
Is Fedora interested in deterministic builds, verifiable builds?
Yes, so that's in that you essentially always get the same binary output every time. Yeah, I don't know if there's any explicit project or active work that's going on. I have had conversations with some people that said that some of the builds are non-deterministic, not because for reasons unknown, essentially, right? That ordering of things, I'm not a low-level sort of binary construction guy, so I didn't entirely understand why, but yeah.
So at some point, maybe each of Fedora release,
Mm-hmm.
the same thing.
Yeah, and I think that also ties in with there's interest in, part of that is knowing, because Fedora doesn't do the triggered builds that I was talking about with the open build service, we do mass rebuilds sometimes, so when something is branched, we'll say, all right, something really big has changed, like GCC has changed or glibc has changed substantially, that would do a mass rebuild, but then smaller changes in increments to something like GCC or the standard library or any library that ends up getting linked into something doesn't necessarily trigger a rebuild, so that's something that gives
So it's being considered, but on the horizon.
on the horizon, yeah. Did I lose my, Drew, please.
What's the organizational structure of
So Fedora, there is a foundation that manages Fedora. I'm not going to do this justice, so turn off the recording, please, just in case I get this wrong. There's a project leader. His name is Matt Miller. There is an engineering steering council, which is sort of right beneath him, which is what all other decisions, any other decisions that aren't sort of collaboratively made or are at all contentious are managed there. And then there are a number of subgroups. So there's a release engineering group. There's the QA group. There's a tools group. There's there's both release engineering and there's explicitly a systems administrator and infrastructure group. And there's a certain amount of overlap in those. But basically, those groups have domain over things like the QA group obviously does the QA process. The release engineering group decides if we're going to have some substantial change to the way that Koji works. Like they decided when we started actually releasing images for clouds instead of just releasing ISOs and packages, that was the release engineering group sort of determined the parameters of that, and then they percolated the decision to add a whole new deliverable up to the engineering steering council. So. And it's all, honestly, it's actually quite well documented, so it's perhaps a little complicated, but it's all on the Fedora project wiki.
Are there other commercial entities that are involved, or is it Red Hat, or?
Red Hat is the main one. I mean, there are other commercial entities on the hardware side, for sure. Right, so the ARM vendors, particularly like as ARM, 64-bit ARM has become available, there have been people who've reached out and given us hardware. Some of that is them purely approaching the Fedora project. Some of it is bleed over from Red Hat and Enterprise Linux, right? But yeah. And there's a ton of people that are interested in ARM stuff, by the way, including me. Like, I would like to add Odroid C1 support to Fedora. So, I'm working on that. Any other questions? Okay, thank you very much.